Hey, fourth grade, here to help you with models of multiplying fractions. So multiplying fractions can be done in a various couple ways. We do have a pattern, a little shortcut that we can do at the end. But before that, we need to see what multiplication of fractions look like in models, so that way we can really understand this pattern. So we're going to start with this first model here, and I have three, looks like, little thirds going on of some type. Now for multiplication, if we have something like 3 multiplied by 4 equals 12, we can also say that as 3 groups of 4. So then when we add up those 3 groups of 4, we get 12. That's how multiplication works. So we can do the same thing here when it comes to multiplying fractions. And we're talking about multiplying whole numbers and fractions. All right, so the first thing I want to do, I want to look at this model, is see how many groups do I have? Because multiplication is grouping numbers. So how many groups do I have? Well, it looks like I have one group here, second group here, and a third group here. So I can write that as 3, and then it's groups of. Now that's what multiplication means. It means that I'm grouping things, so I'm going to use a multiplication sign. So 3 groups of what? Well, how much is in each group? So I'm going to look at just one group. There's one group here, and I notice that it's in thirds, and 2 of them are shaded. So each group is 2 thirds. So I have 3 groups of 2 thirds. Well, when I get my answer, to figure this out, I can just add up all my thirds that are shaded. Now they're going to stay thirds because the pieces aren't suddenly getting bigger, they're not getting smaller, they're staying thirds. So I know my denominator is going to be 3, and then I have 1, 2, 3, 4, 5, 6 thirds. So when I have 3 groups of 2 thirds, I have 6 thirds, because it's 2 thirds plus 2 thirds plus 2 thirds. We're just doing the little shortcut that multiplication is. All right, so now I'm looking at 2, and I have this represented in a different way now. Instead now of a picture model, we're working on a number line. So I notice I have, looks like I'm starting here, going here, and then I'm doing the same thing again. So I'm actually grouping numbers here. Well, I have one group of numbers here, and then another group here. So it looks like I have 2 groups, which I can write that as 2 groups of what? How much is in each group? So I know I have 1/4 there, 2/4, and it stops at 3/4. So it looks like I have 3/4 in this group. Let me check the other group to make sure it's the same. All right, 1/4, 2/4, 3/4. All right, so then that would be 3/4 is in each group. So I have 2 groups of 3/4. Well, when I add that up, let's see, that'd be 1/4, 2/4, 3/4, 4/4, or 1 whole, 5/4. I have 6/4, which is also equivalent to 1 and 2/4. So this time I could use a number line to figure out a multiplication problem with a fraction. I'm going to show you another way that I can do this with a number line. This time, it looks very similar to what we just had, except someone just kind of squished those, what I like to call like camel humps down, and now we just have flattened arrows. So I could see that from 0 to here, all right, that looks like 1 group, 2 groups, 3 groups, 4 groups. So hopefully by now you're seeing that the whole number is going to be 4. I have 4 groups of, and how much is in each group? All right, so I have 1/5, 2/5, 1/5, 2/5, 1/5, 2. So it looks like 2/5 are in each group. So if I have 4 groups of 2/5, well, that would be 1, 2, 3, 4, 5, 6, 7, 8 fifths. Looks like I have 8 fifths, or I can also write that as 1 and 3 fifths. I can write that as 1 and 3 fifths. All right, so this is how we can take these different models and create the multiplication problem, a whole number by a fraction, and actually find out the product. Now I'm sure a lot of you are already seeing the pattern going on. There is a pattern when we take a whole number and multiply by a fraction. So just like when it comes to adding and subtracting, our sizes of our pieces don't change. Our denominators of the fraction are always going to stay the same. We had thirds, our product's in thirds. We had fourths, fourths. We had fifths, fifths. So for this example, I'm having 6 multiplied by 2/8. Well, I know the pattern is going to be that my denominator is going to stay the same. If I'm dealing with eighths, well, it makes sense that I have eighths for my product. So I have 6 groups of 2/8. That's like doing 2/8 plus 2/8 plus 2/8 plus 2/8 plus 2/8 plus 2/8. Or we can do repeated addition, which is multiplication, where I can take my whole number and multiply it by my numerator. A lot of students see this right away. So I can do 6 multiplied by 2, and I would get 12/8. 12/8. And if we wanted to change this into a mixed number, I could see that I could take out 8/8. I could take out 1 whole, and I'd be left. So I have 1 whole, and I'm left with 4/8 remaining. So also equal to 1 and 4/8. Both answers are acceptable, because after all, they are equivalent. So in 4th grade, not only are we looking for the students to be able to do these multiplication, a lot of them see the pattern, they can do it. They also need to be able to recognize, what does it look like? What does 3 multiplied by 2/3 look like? Well, it's 3 groups of 2/3. All right, hopefully this video helps out, and hey, I'll see you next time.